ideal gas, perfect gas, universal gas. All of these three terms are referring to the same behavior of gas. But in this session, I will use the terms ideal gas in our discussion. Before we go further to our discussion about the gas law, let's recall about the kinetic molecular theory. The first one, the gas particles are in constant and random motion. This means that the gas particles is always collide with each other and to the wall of the container. The second one, the volume of gas particles is negligible. This is due to the gas particles is very small compared to the volume of the container. The third one, intermolecular forces between the gas particles are negligible. The fourth one, collision between gas particles are elastic. Elastic here means that the kinetic energy of the gas particles before and after the collisions are same. And the last one is the average kinetic energy of the gas particles is always directly proportional to the absolute temperature. All of these 5 kinetic molecular theory will be used as assumption to the gas laws. As we discussed in our previous session, we'll already learn about the Boyle's law, which relates between volume and pressure, and it states that volume inversely proportional to the pressure. Then we learn about the Charles law, which states that volume directly proportional to its absolute temperature at constant pressure and amount of moles. And the third one, we have Avogadro's law, which states that volume directly proportional to the amount of moles at constant pressure and temperature. All of these 4 variables can be combined and we have the relationship of V directly proportional to T over P. Class, we cannot see the gas particles anywhere with our naked eyes, but we can feel the existence of the gas particles by the effect of its behavior. When we discuss about the ideal gas, it always relates with the terms of pressure, volume, number of moles, and also the temperature. As we discussed before, we already have this relationship between the 4 variables, which is volume directly proportional to NT over P. After we convert this relationship into the equation, we will have V equal to KNT over P, and after rearrange the equation, we will have PV equal to nRT. I have changed the K with R here as we discuss about the gas, and R here is referring to the gas constant with the unit of ATM, liter per mole per Kelvin. The unit ATM here is referring to the P, L is referring to the volume, mole to the power of -1 is referring to the N, while capital K to the power of -1 here is referring to the T. So, if you use this PV equal to nRT with the gas constant 0.08206, you have to make sure that all the variables must use the unit same with the constant unit. So class, here is the ideal gas equation. PV equal to nRT. This equation relates all these 4 variables, which are pressure, volume, number of moles, and temperature. R is the gas constant, which in this discussion, I will use the value of 0.08206 ATM, liter per mole per Kelvin. Always remember that when you have 3 of these 4 variables, you are always be able to find out another variables by using this equation, which is ideal gas equation. Next, let's relate the ideal gas equation and molar mass. As we know, this is ideal gas equation, PV equal to nRT, and we know that N is equal to M over molar mass. By substituting this n into the ideal gas equation, we will have PV equal to m over molar mass RT. And after we rearrange the equation, we will have molar mass equal to mRT over PV. So now we know from the ideal gas equation, we can also find the molar mass of our gas by doing this relationship between ideal gas equation and the molar mass of the gas. So now this is the last part of our session, which to see how ideal gas equation, molar mass and density relates with each other. As we know, we have PV equal to nRT as our ideal gas equation. And we have mole equal to mass over molar mass. And then by substituting mole, we have PV equal to m over molar mass RT. We know that the density is mass over volume, and we rearrange the equation so that we can have mass over volume in our equation. And the last one, we just substitute the mass over volume as the density, and we will have the equation molar mass equal to density RT over P. So now we know that we can also relate the density of the gas in our ideal gas equation. One thing to remember, understand first, do not just memorize the formula. Thank you and happy studying. That's all for now. See you in the next session.